Right. We'll move to the next question. This question from CSIR examination 2019 June. This question also based on the basics of chemical kinetics. If the half-life of a reaction is inversely proportional to the square of the concentration of the reactant, then the order of the reaction is a very simple question and very basic question also. What they are asking, the half-life of the reaction. For half-life of the reaction and the order is given. What is the clue given here is the half-life is inversely proportional to the square of the concentration. That is the clue given here. So what is the T half? So we can arrive the relation T half of the reaction is inversely proportional to the concentration of the reactant. We put the concentration of the reactant as concentration of A, whatever it may be. Concentration of A will given here. Whatever we can write like this. Concentration of A proportional to the square of the. So this relation we have to arrive. This is the question. T half is directly proportional to 1 by A square, which belongs to which order, whether it is a 0 order, first order, second order or third order. That is the question. This is the general expression for T half calculation. This is we have to need to memorize 2 power n minus 1 by k n minus 1 A0. This is A0 initial concentration power n minus 1. So by substituting 0, 1, 2, 3 value, we can get the T half for the various order of the reaction. This general expression is not applicable for first order reaction. This is except first order, because for first order reaction, T half is 0.693 divided by K. Here the T half is independent of initial concentration, but here the question is inversely proportional to the square of the concentration. For first order it is independent of initial concentration. So initial concentration term which is not observed in the T half of first order reaction. So for first order reaction 0.693 divided by K. So the reaction, the given expression which is not a first order. So we omit the first order expression. So what about for zero order reaction? For zero order reaction, the T half which is written as T half is equal to A divided by 2K. So which is simply concentration of A divided by 2K. But here in this zero order reaction, T half is directly proportional to concentration of A. So we can omit 0 also. So this given expression which is not applicable for 0 order, which is not applicable for first order also. Okay, now we move to second order. So for second order, what is the T half expression? T half of second order which is equal to 1 by Ka. This is T half is inversely proportional to concentration of A. So for for second order, T half is inversely proportional to concentration of A. But what we need, inversely proportional to the square of the concentration. Inversely proportional to square of the concentration. Okay, we move to third order reaction. So we omit second order. So obviously the answer is third order. So for third order reaction, our T half is equal to 3 by 2 Ka square. Okay, we'll arrive the answer. T half is proportional to A square. So we will get the answer. So this is the T half for your expression, T half 1 by A square. So the answer is D, third order reaction. So this is the expression we expected here. So for the given initial concentration, so here for the given initial concentration, inversely proportional to the square of the concentration of the reactant. Hence the order of the reaction is third order reaction.